Okay, Assalamualaikum warahmatullahi wabarakatuh. So, okay, this time, this is the second part from the topic 3. So, before this, you already learned about the correlation, which is the first part. From the correlation, kita ada two different ways. The first one is graphical method, and the second one is non-graphical method. So in terms of graphical method, what you need to do is to draw a scatter plot. So based on the scatter plot, you will observe whether there is a linear relationship between x and y, or there is no linear relationship. So the strength of the relationship you can observe from the non-graphical part, which is to find the value of r. So based on the value of r, which is for the correlation, you can find the strength of the relationship, either it is weak, moderate, or strong relationship between y and x. Okay. So this time I'm going to continue with the next one, which is our second part about the regression. So, okay. So the first thing is, so this time I'm going to just draw the manual calculation in slide or in our word letter based on our example. So for the regression line, what you need to do is, as you know, before this, you ada scatter plot. Okay. So based on this scatter plot, you ada dot-dot lah. Let's say kita ada dot-dot lagi. So from this dot-dot, you are going to draw a line. So based on this line, dia adalah regression line. Ataupun dengan kata lain, dia adalah line of best fit. Line of best fit. Okay. So from this line, what you need to do is kita punya equation. You need to find the equation. So our aim is to find the equation yang mana equation kita should be y hat, which is equal to a plus bx. Ataupun dulu kan you already learn in mathematics. So what you learn is y equals to mx plus c. So you ingat lagi. So m represent kita punya gradient ataupun kita punya slope. Slope is the slope lah, kecenderungan. Okay. Kecerunan. Okay, kecerunan. Okay. So kecerunan. Okay, sorry. So C pula ni adalah intercept, which is kita punya persilangan. Intercept. So kita punya titik persilangan ada pada bahagian sini. So this one should be our C ataupun kita punya A, and then this one should be kita punya slope, which is kita punya M ataupun B. Dengan kata lain, saya nak kita menggunakan kalau dulu kita memang gunakan yang ni, tapi sekarang kita tak gunakan yang ni. Kita tukar sikit term. Kita dah masuk tingkat university, right? So bila tingkat university, term yang sama. So you tak perlu nak risau, dia masih lagi sama. Tapi kita akan buat in term of beta naught hat plus beta 1 hat x1. So from this equation, dia sebenarnya sama macam ni lah. So y hat tu represent dia punya, bila kita cakap pasal y hat ni, dia adalah point estimate. Point estimate dalam statistik, dia adalah point estimate. Maksudnya macam value lah, estimation of value, anggaran value tu apa. Okay. So untuk y, which is equal to beta naught hat plus beta 1 x1. So beta naught hat ni adalah kita punya intersection ni, intersection ataupun intercept, kita punya titik persilangan. And then kita punya B1 represent kita punya slope ataupun kita punya gradient, which is this part. So regression line tu consider macam ni, yang mana dia sebenarnya adalah satu model. Okay. So sebab tu saya cakap, bila kita buat statistik, apa-apa je dalam masuk dalam statistik, apa yang you all kena cari adalah conclusion. So based on our conclusion, apa benda yang boleh kita dapat. So conclusion yang kita boleh dapat adalah satu model based on kita punya data. Okay. So continue from the first part kan, kita kena cari kita punya regression line daripada scatter plot tu, and then you akan dapat nilai R kan. Before this, you cari nilai R, which is R tu adalah coefficient of correlation. So bila you cari coefficient of correlation, which is kita punya R, macam mana dapatkan coefficient of determination, dia adalah dibalik antara ni dengan ni. Okay, so macam mana dapatkan coefficient of determination? Kalau dulu kita cari coefficient of correlation adalah R. Kalau coefficient of determination, you just buat je R kuasa 2. So, you akan dapat jawapan tu. Jawapan tu, you kena buat dalam bentuk percentage. Okay, so nanti kita akan tengok balik kat this one. Okay, the next slide is about least square method. So, cara macam mana kita nak dapatkan regression line adalah sebenarnya namanya least square method. Dia sebenarnya ordinary least square method. Ordinary. Okay, so OLS method ataupun ordinary least square method. Okay, so kita tinggal ordinary kat sini. So, untuk yang ini, okay, regression line masih lagi sama, nampak tak? Regression line. And then, kita ada formula nak dapatkan A dan dapatkan B. Dengan kata lain, D kita ni adalah kita punya beta 1 hat. And then, E kita adalah kita punya intersection tadi kan? Which is, kita punya ni lah, beta not hat. Okay? So, as you can see, jangan keliru. Yang kat bahagian sini adalah dia punya intersection. Yang mana yang ada dekat dengan X ni adalah kita punya kecerunan. Okay, so bila kecerunan dia otomatis dia adalah beta 1. But then untuk dia punya intersection ataupun intersect dia yang bersilang tu adalah kita punya A. Ataupun dengan kata lain dia adalah B not hat. Okay. Okay, so formula untuk dapatkan B ataupun untuk dapatkan beta 1 adalah seperti yang macam ini. And then formula untuk dapatkan A adalah this one. So this formula dengan this formula sebenarnya boleh disimplify. Kita boleh simplify both of this formula. Nanti saya akan tunjukkan formula yang lebih senang untuk kita gunakan, which is kalau kita nak gunakan beta 1 hat ni adalah sama dengan SXY divide with SXX. Okay, this one adalah formula untuk beta 1, and then the next one adalah beta naught. Yang you kena ingat adalah Y hat minus beta 1 hat, and then you darabkan dengan X bar. So this one adalah yang simplify lah, simplify punya formula. Saya ada juga kat belakang nanti. Okay, so nanti saya akan explain lagi sekali lah. Nampak tak? Kita gunakan XY, this one sebenarnya adalah SXY. Sebab tu dalam previous nak dapatkan nilai R, saya lebih fokuskan you cari in term of SXY, SXX dengan SYY. Nampak kan? So this formula ni lepas dah gunakan dah dapat cari R, you boleh gunakan untuk dapatkan beta 1 dengan beta naught ni untuk regression line. Okay, so seterusnya adalah coefficient of determination. So the use is to assess the accuracy of the model on how well the model can be used to predict the future outcome. So it is used to measure the proportion of variation in Y explained by independent variable of X. Maksudnya sekarang, kalau coefficient of determination ni lebih fokus kepada macam mana, adakah berapa banyak percentage dia nak cakap pasal dia nak cakap pasal berapa banyak percentage yang kita ada of Y dijelaskan oleh X, dia macam tu. Berapa banyak percentage daripada Y ni, result Y ni yang dijelaskan oleh X, dapat dijelaskan oleh X. Maksudnya berapa banyak persen X ni effect kepada Y, dia macam tu lah. So sebab tu kita cari dia punya R square. So daripada nilai R, which is coefficient of correlation, you boleh cari coefficient of determination dengan menggunakan R square, which is squarekan sahaja nilai dia. Kalau R you dapat 0.91, you square tadi you akan dapat 0.828. Okay, so R square is expressed as a percentage. Sebab tu saya cakap percentage. Jadi bila you express dalam bentuk percentage, untuk dapatkan nilai R square, nilai tu mesti higher, tinggi. Macam you dapat mark lah kalau periksa kan. Kalau dapat 30 lebih maksudnya sikit lah. Jadi kita kena dapatkan 90 lebih. So yang better adalah from 60% to 90% to 100% lah. Maksudnya lagi banyak, lagi tinggi, lagi bagus. Okay, so macam mana cara nak explain, you kena ingat. Sebab dalam statistik, macam saya cakapkan dalam tutorial yang keempat, dalam statistik you kena justify your answer. Kenapa jawapan dia macam tu, apa result dia, dia suruh comment. Okay, so macam mana cara nak explain adalah R square equals to 0.828 means that 82.8% of the total variation in Y can be explained by X, while the other 17.2%. So 17.2% adalah pure balance. So you just ambil je 1 minus 0.828, you akan dapat 0.172. Ataupun you ambil 100%, tolakkan dengan 82.8, you akan dapat 17.2%. So ini adalah yang selebihnya lah. of the total variation is explained by other factors. So kena ingat point ni. Y ni you kena state lah apa benda YU, and then X ni pun kena state juga apa benda XU. Okay, so untuk yang ini pula, kalau lah dia ada dalam bentuk ada unit yang berbeza kan, let's say dia gunakan apa nama dia, percentage ke, you boleh terus buat je 52%, let's say macam tu lah. So kena state dia punya unit, buat dalam kurungan pun okay lah. Nanti saya akan explain in term of dia punya details based on dia punya explanation and based on example kita. Okay, so kita akan proceed. Okay, nampak tak? Saya punya example ni adalah based on kita punya previous example. Saya sambung sahaja. Kalau you perasan, example 4 ni equal to example 1, yang mana you dah dapatkan scatter plot, you dah dapatkan nilai R. So sekarang ni kita sambung je based on this question lah. Dan seterusnya untuk 5 pun sama, question 2 dan question 3. So saya akan proceed dulu kepada yang selepas tu. So additional formula adalah untuk ordinary least square method. Additional formula yang saya cakap tadi adalah ringkasan je kan. So daripada you hafal benda ni, kadang-kadang tak hafal benda ni kan. So kita dah dapat cara yang lebih senang, which is yang ini sahaja. So you kena hafal apa di SSS, apa di SYY. Okay, yang ni kena hafal. So based on this one, beta 1, okay, before that ada yang ini kan. Okay, yang ini based on this formula, coefficient of correlation, yang ni you all dah cari dah. So ini adalah first method punya formula, and then yang ni adalah second method punya formula. So saya prefer, saya tunjukkan dua-dua kan. Untuk example yang pertama saya gunakan yang ni, untuk example kedua dan ketiga saya gunakan yang ni. But then saya prefer you gunakan formula yang bawah ni, sebab senang untuk kita dapatkan beta 1 hat. Okay, untuk dapatkan beta 1 hat ni kita menggunakan SXS, SXY bagikan dengan SXS. Okay, so ini adalah formula dia. So waktu saya suruh cari yang dulu, ini berapa, ini berapa, ini berapa. Based on this formula you akan dapat lah. Senang saja nak ingat, SXY adalah sama dengan hasil tambah XY tolak hasil tambah X, tolakkan hasil tambah Y bahagikan dengan N. Nampak tak, ini adalah X, ini adalah XY, ini adalah Y. So sangat senang nak ingat benda ni. Okay, so proceed kepada yang ni. Once you dah tahu dah your formula untuk apa nama, cari ni, instead of using yang ini kita boleh gunakan yang ni. Okay, so kita gunakan formula ni lah untuk dapatkan kita punya beta 0 dengan beta 1. So make sure cari dulu beta 1 baru dapat cari beta 0. So beta 1 adalah SXY bagikan dengan SXS, you akan dapat jawapan. And then untuk beta 0 pula, nampak tak yang ini kan, sebenarnya dia represent kita punya yang ini. Ini adalah macam mean lah, macam mean ataupun average. You ambil hasil tambah Y bahagikan dengan N, and then tolakkan dengan beta 1 ni, kena dapatkan kat sini. So saya cari beta 1 dulu, dan darabkan dengan X bar, which is hasil tambah X bahagikan dengan N. Dia akan dapat jawapan lah untuk part ni. So at the end dia akan dapat satu model, which is kita punya regression line dia. Okay, yang ni. Okay, so proceed kepada relationship. Assumption yang you perlu tahu untuk regression analysis. So untuk regression analysis, dia apa-apa je lah. Dia ada linear regression yang ada multiple. Okay, ada dua jenis lah yang you perlu tahu, linear dengan multiple. Kalau linear, kita punya apa nama dia, model ataupun kita punya regression line, biasanya kita akan buat Y hat sama dengan beta 0 plus beta 1 X1. Itu adalah linear. Tapi kalau you ada multiple, you kena tambah lagi satu, beta 2 X2. Let's say ada lain lagi variable, beta 3 XC. Nampak tak? Ini variable yang ada lainan. Ada 3, ada 2, ada 1, ada 3 variable. So untuk linear, maksudnya linear tu satu sahaja, melibatkan satu variable, so stop sampai sini sahaja, tak ada yang belakang ni. Sebab tu saya sarankan untuk gunakan beta 0. Kalau you gunakan Y sama dengan A plus BX, nanti lain nak CX plus BX, agak weird kat bahagian sini. Okay, walaupun nampak okay, tapi sebenarnya kita jarang gunakan C dan B. Okay, so kita gunakan yang ni lah, mana-mana boleh ya. But then you cuma belajar linear sahajalah untuk your tahap your level. Okay, before proceed in making prediction, it is vital to check for all the model assumption, because serious violation of this assumption will make our prediction become invalid and not useful. So sangat penting you kena tahu dia punya assumption dulu, which is leanness. Dia punya keyword dia adalah leanness. Okay, looking for the first one, which is linear, the relationship between the response variable of y and the regressor variable x is linear and is approximately. So for this one, the first one is already, you already find the first one based on our scatter plot. So based on the scatter plot, what you learned is either there is a linear relationship or not. So at the end, you will get bila ada linear relationship, so assumption untuk yang pertama adalah acceptable ataupun diterima ataupun telah dibuktikan lah, proof. And then the second one is independent. So this linear, you just assume based on your result in either graphical or non-graphical way, which is by scatter plot ataupun by using R value, which is coefficient of correlation. So the second one is independent. So for this independent, the errors are independent. So that means for this part, the independent means, like what I said earlier, we have dependent and independent variable, right? So independent variable represent our x. So in terms of independent variable, let's say you perform a multiple linear regression. That's why saya terangkan juga based on multiple linear regression for you to understand the assumption. So based on independent variable, if let's say you have x1, x2, x3, so this one adalah kita punya variable, x1, x2, x3. So between x1 and x2 and x3 mesti independent within each other. So that means let's say x1 adalah berkaitan dengan gender, and then x2 berkaitan dengan races, and then x3 berkaitan dengan contohnya dan that lah demographic variables lah. For example, semester berapa, you semester berapa, boleh juga. So untuk these different types of variable, dia mesti independent. So that means tak ada kaitan antara satu sama lain. Independent tu maksudnya berdiri dengan sendiri, berdikari. Kalau dependent maksudnya dia bergantung kan. Kalau independent dia tak bergantung. So that means gender adalah gender lah. Kalau orang yang gender dia male, adakah dia Melayu macam tu? Tak ada kaitan. So maksudnya antara gender, antara races dengan semester tak ada kaitan. So you kena find out that independent variable ni mesti the errors are independent. So that means dia tak ada kaitan antara satu sama lain. So for this method sebenarnya you kena perform chi-square test ataupun nama dia adalah chi-square test. Okay. So this one adalah optional lah because kita sedang belajar, kita tengah belajar, we are learning about the linear regression only. So bila linear regression, so this independent variable might not be included in this study lah. Okay. So the next one adalah the third one, which is kita punya normal distribution. So this part, normal distribution, the errors are normally distributed. You kena perform Kolmogorov-Smirnov test. Actually, you need to know this assumption because we are learning about linear regression. So it is one of the important part. You need to identify macam mana cara nak perform independent test ni. Untuk normality ni pula, Kolmogorov-Smirnov test ataupun you plot PP plot ataupun QQ plot. So bila you perform PP plot ataupun QQ plot, dia punya plotting tu mesti scatter secara dia punya scatter plot is homogeneous ataupun dia punya scatter plot tu dia macam I think like this. Dia secara scatter, tak ada pattern. Okay, tak ada pattern. So dia punya PP plot adalah like this. So bila PP plot is like this, you need to we will say that the data is coming from normal distribution. So the normality assumption is accepted. Ataupun kita boleh juga tengok daripada skewness. So daripada skewness, you kena observe skewness from positive 1 until negative 1 only. So antara positive 1 and negative 1, bila dia punya skewness tu lebih daripada negative 1 ataupun lebih daripada positive 1, so it is not normal, it is skewed. Okay, dari segi skewness kan kita baca kan, kalau skewness macam mana nak tengok based on kita punya nilai R. So kalau dia adalah skewed, normally dia adalah bukan normal distribution. Okay, kita mesti find dia punya skewed tu adalah 0 ataupun you boleh gunakan. Kalau kita dapat jawapan kan, kita akan dapat approximately 0 point berapa, kadang-kadang boleh menggunakan 0 approximate ni mesti 0 lah, baru dapat normal distribution. So untuk yang keempat adalah equal variances. Equal variances ni in terms of dia punya error term. So error term has constant variance or homoscedasticity assumption is satisfied. So that means bila you tengok pasal equal variances, as variance kan saya cakapkan berkaitan dengan error term. Error. So bila variance berkaitan dengan error, macam variation lah hari tu kan. So dia mesti tak ada pattern. Bila you plotting, macam saya cakap tadi kan, untuk yang PP plot, I think PP plot is like this one lah, linear regression. I think I'm wrong at this place. Kita check balik. But then untuk observe correlation of test, PP plot dengan skewness lah untuk normal distribution. But then untuk equal variances, apa yang you perlu cari adalah dia punya error term. Okay, dia mesti no pattern. No pattern dekat this homoscedasticity assumption ni dekat dia punya plotting. Okay, plotting dia kena tengok lah. Ni plotting error plotting error. So this one adalah equal variances, and then next one first adalah zero mean. So zero mean means the error term has zero mean. This one normally kita assume je. Okay, so maksud saya bila you nak tengok, okay, the next one, the fifth assumption berkaitan dengan zero mean. So what you will say is we will just assume that the data has zero means. Means the error term has zero mean lah. So kita just assume sahaja for us to proceed the analysis. Okay, so bila dah 1, 2, 3, 4, 5, bila 1, 2, 3, 4 ni dia approve, means satisfied, dia punya assumption satisfied, baru dah kita boleh proceed kepada 5 ni, and then 5 pun kita boleh cakap dia adalah zero mean. So this method adalah normally untuk parametric distribution. So maybe you pernah dengar parametric distribution. Okay, parametric distribution means kita kena gunakan linear ni. But then if salah satu daripada this assumption is not satisfied, so you kena gunakan non-parametric. Okay, this one adalah untuk your pengetahuan parametric. You are not going to learn about the non-parametric, sebab kita just sentuh berkaitan dengan linear regression, which is one of the parametric method. Okay, so sebenarnya yang chi-square ni adalah one of the non-parametric method. So that is why sebenarnya untuk yang part ni adalah optional lah, tak perlu ni, melainkan kalau you nak cari untuk regression analysis. Untuk yang parametric sebenarnya boleh gunakan Durbin-Watson. Sebenarnya banyak test lah, but then you kena tengok dia punya key point, which is linear. First sekali kita tengok sama ada data tu linear, the second one is independent, and then normal, and then equal variances, and then we must have the zero mean. Okay, we must assume that the data has zero mean, means that the error term lah. Okay, for the next slide, the use of regression model. The use of the regression model for prediction purposes. Regression analysis helps to make data-driven prediction about the future of giving a clearer and more accurate path in the future. So ni adalah dari segi dia punya use lah, apa kegunaan regression model ni. Bila kita dah dampakkan model tu adalah Y sama dengan apa. Let's say nanti you akan dapat model, you akan boleh make prediction. Maksudnya let's say lah kalau X tu adalah sama dengan berapa, you akan dapat Y sama dengan berapa. Nanti saya akan tunjukkan soalan ni, dalam contoh soalan ada. Sebab tu kita cakap kita boleh tahu prediction about the future, lah. And then the next one adalah regression analysis is clearly a significant factor in business because it allows firms and their managers to make better informed decision based on hard number. So kita boleh buat decision based on dia punya result. Okay, regression analysis juga forces to take a look at the actual data rather than simply guessing. Tak boleh nak just guess saja, tak boleh nak teka saja. Kita kena really work on that data, baru kita dapatkan conclusion dia. So last one, linear regression are using single line that we draw through the plot point, which might go up or down. This will be clear visual to look at the result. Instead of kita tengok daripada nilai R, you boleh juga tengok daripada graphical kan. So you akan tengok sama ada dia move upwards ataupun sama ada dia move downward macam ni. So kita boleh nampak yang contohnya kita ada kaitan dengan dia punya sale tu kan. So bila berkaitan dengan sale, adakah sale tu increasing ataupun sale tu decreasing, apa yang perlu kita buat. Dia kena take an action. Sebab tu bila dah dapat result, kita boleh make decision ataupun come up with some recommendation untuk idea ni lah, untuk improve kita punya business or some apalah, whatever. Okay, so the next one adalah few example in terms of application. Predict the sale of the product, predict the student's academic achievement, identify the factors, and then identify determine which factors such as age, smoking status, level of exercise, diet significantly and affect the cholesterol level. So this one biasanya untuk multiple lah, nampak kan? Kita ada variable age, variable smoking, variable level of exercise dengan diet, lepas tu effect pada cholesterol level. So ini adalah kita punya Y, cholesterol level. Ini adalah kita punya X. So ni boleh jadi X1, X2, X3. So adakah XX ni ada effect pada kita punya Y? So itu adalah one of the multiple linear regression lah yang you all perlu tahu. Okay. Okay, so I just nak tekankan balik. Before this, I cakap yang tadi kan. Sekejap erase sikit. So, for the linear part, apa nama dia? Yang saya cakap part, yang this one kan? This one is wrong okay. Sekejap So, for equality of variances, betul. Saya cakap pasal mesti tak ada pattern. Macam mana you nak observe adakah ada equal variances ataupun tak. Equal tu maksudnya homoscedasticity So ini boleh cakap pasal homoscedasticity assumption ataupun equal variances punya assumption. So bila dia tak ada pattern, yang bermaksud equal variances ataupun the error term has a constant variance. Dia mesti pastikan akhir sekali mesti ada constant variance. Maksudnya error tu variance kan ataupun variation, error tu adalah constant. Okay, so kena tengok dia punya scatter plot ni mesti no pattern. But then untuk normal distribution sama macam linear, dua benda ni lebih kurang sama. Both of these you need to observe the scatter plot and then find the best fit juga, macam linearity jugalah. Okay, so this part pun sama juga, find the best fit linearity. Okay, so this one saya tersilap lagi yang bukan yang randomly scattered. But then untuk PP plot ni dia adalah yang ini. Okay, sama juga macam linear lah. So linear dengan normal distribution adalah sama. Okay, so kita akan back kepada assumption. So for assumption pula, for example 4, 5 dengan 6 ni, which is based on our example 1, 2 dengan 3. Saya akan continue dalam Word, dalam sini jugalah. Saya tak buat manually kali ni, so saya akan buat dalam laptop saja. So okay, let's continue after this. Okay, refer to example 1. Kita punya example 4 is based on example 1, which is basically I'm using the similar data. Number of employed, which is our X, and then our Y is number of cars infected. And then based on the equation, we have A, B, C, D. A is linear regression line using least square method, and then B explain the meaning of the constant A and B. So untuk constant A and B represent our data 0 and data 1 in the equation. And then C, calculate the coefficient of determination. So before this, you find the coefficient of correlation, our R. So this time, coefficient of determination, you need to find R square. And then D, estimate how many cars a person can be expected to inspect during the same 2-hour period if he or she has been working at the inspection station for 8 weeks. So that means, like what I said earlier, the use of linear regression is to predict the future outcome, right? So in order to predict future outcome, for example, yang ni kan, you want to observe bila we have 8 weeks number of employee, we have 8 weeks. So how many cars yang be inspected? Estimate how many cars a person can be expected to inspect. So means berapa banyak number of cars inspected tu kita boleh cari. So that one adalah future outcome. Okay, so this is one of the example yang I said earlier lah. So kita akan proceed kepada dia punya jalan kerja. So basically I am using the previous example 1, right? So example 1, like kita perlu cari adalah So the first one, kita akan keluarkan dulu nilai-nilai dia. So for example 1, nilai yang kita ada adalah summation of x, which is 36, summation of y, which is 107, summation of x squared, which is 304, summation of y square. E ni maksudnya summation summation of y square, which is 2001, and then kita ada summation of xy, which is 721, and then we also have our n apa, and 6. Okay, so this one you need to observe. So based on example 1, like what I said earlier, untuk example 1 yang R ni, saya kan gunakan formula yang panjang kan, but then you boleh gunakan formula SXY divide with SXX times with SYY macam kuasa. So this one adalah formula untuk simplify, simplest in terms of the formula, the simple formula. So SXY, SXX and SYY. So the first one, since kita tak cari lagi, based on example 1 ni, tak cari lagi SXX ni kan. So kita akan carilah sebab soalan yang E, dia nak cari regression line. So that means kita akan dapatkan y square is equals to beta naught hat plus beta 1 hat x. Okay, so this one sebenarnya sama macam saya cakap lah, y sama dengan E plus bx. Okay, so don't confuse about these two formula, still the same. Kalau saya suruh explain A dengan B tu maksudnya antara dua benda ni lah. You need to differentiate lah. Yang sebelah x ni kita punya slope, which is beta 1. So first saya nak kena dapatkan dulu beta 1. So beta 1 punya formula adalah SXY divide with SXX. Okay, so kita kena cari dulu formula yang ni. So the first one adalah SXY, which is equal to summation of xy minus summation of x ditimeskan dengan summation of y, and then divide with n. Okay, so from this part, summation hasil tambah xy adalah 721. So you have 721 minus bila kita punya summation of x dengan summation of y. So summation of y adalah 36, and summation of y adalah 107 divide with our n, which is 6. So at the end of this calculation, you will get SXY, which is 79. Okay, so untuk SXX, it is similar. Kita ada summation of x square minus summation of x, you square kan dia, and then divide with n, and then we have summation of x square, this one. So 304 minus summation of x, which is 36, you square kan, and then divide with 6. And then at this calculation, you will get 88. Okay, so for beta 1 hat, so we have this value. So you just put it in the formula, 79 over 88, and then you will get beta 1 hat, which is equal to 0.8977. Okay, so this one adalah beta 1 hat, and then follow with our beta naught. So in order to find beta naught, the formula should be y hat minus beta 1 hat and then x bar. Okay, this is the simplest formula. So y bar means it is the average of y. So just pick on this 107 divide with 6, nak dapatkan average kan, minus, and you take our beta 1 hat, which is 0.8977, and times with our x, average of x, which is 36 divide with 6. And then you calculate dulu yang belakang ataupun you calculate daripada depan, tak kisah. At the end of this calculation, you will get 12.4471. Okay, if I'm not mistaken, this is the value for our beta naught hat. Okay, if I make some error ataupun calculation, you can just tell me. Okay, so for now I get this value. Okay, so bila once kita dapat this value, at the end you boleh cakap lah, so the regression line is, so you buat y hat, which is equal to beta naught, right? So kita akan start dengan 12.4471 plus our beta 1 hat, which is 0.8977x. Okay, so this one is our regression line. Okay, so that one adalah for the first part. Ini adalah kita punya A, and then kita move towards our next question, which is B. So for our next question, regarding the explanation, so change the color. So in terms of explanation, once you want to explain the value of beta naught and beta 1, right? So we will begin with beta naught first. Beta naught is equal to 12.4471. So means that when there is no number of employed, which is x equal to 0, the number of cars inspected will be 12.4471. Okay, so this one focus on our x. Bila x equal to 0, so that means let's say lah you ada y sama dengan 12.447 plus 0.8977, and then your x is 0. So automatic yang belakang ni dah tak ada dah. So kita akan dapat y tu sama dengan 12.447. That is why saya cakap when the number of employed, no number of employed, maksudnya tak diambil apa-apa, which is x equal to 0. The number of cars, which is kita punya y, will be 12.4471. Okay, so that one adalah explanation. In terms of yang ni memang fix, you akan buat macam ni, 12.4471 ataupun apa pun nilai, means that when there is x equal to 0, apa dia x kita equal to 0, ataupun you boleh cakap yang no number of employed when the price is equal to 0, ataupun apa pun yang equal to 0, dia mesti equal to 0 kat sini, dia fix kat bahagian sini. The number of car means the y, apa your y, beritahu kat sini, will be kita punya nilai lah, which is 12.4471 for this example. Okay, so that one adalah way how to explain beta naught, and then move kepada beta 1. So kita ada beta 1 which is equal to 0.8977. So means that every increase in 1 week of employed, which is our x, the number of cars inspected will be increased by 0.8977. Okay, so for the second explanation, as you can see right there, kita ada 0.899 and 0.8977. So means that every increase in 1 week of employed. So maksudnya every increase, sebenarnya point kat sini adalah every increase in, kat sini you boleh highlight kan, every increase in apa? Every increase in 1 unit. Every increase in 1 unit of kita punya x, unit of x. Okay. Every increase in 1 unit of x, the number of cars inspected, this is our y, number of y will be increased by 0.8977. Okay, so this one sama juga fix. Yang ni berapa nilai kamu boleh jadi berubah, means that every increase in 1 unit of x, 1 unit ni can be 1 week, can be 1 ringgit, can be anything based on your unit. Okay, so increase in apa? Okay, okay, that one adalah for our B, which is explanation in terms of A and B, right? So A represent our intersection, which is kita punya beta naught, and then beta 1 hat will represent our B. Okay, so move forward to the next question, which is C. Yang mana kita perlu cari, this one adalah untuk ni, this one adalah untuk B. Okay, so this one adalah explanation untuk B. Ini saya dah beritahu one lain kan. Okay, so untuk yang the next one adalah based on coefficient of determination. So in terms of coefficient of determination, kita ambil balik back to our value in example tutorial number 4. So based on that example, kita ada dapat nilai R which is equal to 0.8740. So in terms of coefficient of determination, we need to find R square, which is R u square 10, and that means you need to square this value. So at the end of the calculation, you will get 0.7639. Oops, I'm sorry. It moved. Is that this one? Wait. 0.7639. Okay, so macam mana cara nak explain? You kena buat benda yang sama lah, like what I said earlier. In terms of explanation, this you need to present it in percentage. So you just put the means that 76.39% of the total variation in Y infinite state, which is number of car inspected, is explained by X, which is a number of week employed while 23.61% of the total variation is explained by other factors. Okay, so in terms of this nilai, value of this one, actually you need to buat some other 100% minus 79 and 76. Okay, so continue. We have 9 right here, right? So 100% minus 76.39, so that means you will get 33.61%. Ataupun from this one, you just 1 minus 0.7639. Okay, we akan dapat 0.2361 lah. So from this part, as you can see, dia punya explanation is similar with what I already explained in the slide kan. So that means 76.39%, which is this one. In terms of percentage, you just times with 100 and then you dapat percentage of the total variation in Y ni guna state lah, which is number of car inspected is explained by X, which is the number of week employed, while ini D, while 33.61% of the total variation is explained by other factors. Okay, so ini adalah untuk our answer for C, and then move to D. D is based on the question asks you to find whether what happened in each week, right? So estimate and how many cars can be expected to inspect during the same 2-hour period if he or she has been working at the inspection station for 8 weeks. So dia nak bila X2 equal to 8, how many of the cars is being inspected. Okay, so just use the equation. So based on this equation, y hat equals to 0.4471 plus 0.877. You just put in the value, which is when x, you see it, x equals to 8 weeks. So ni kena depends on the unit lah. Kalau your calculation, your unit from the first place dalam this new data is in terms of week, so you need constantly using week. Okay, so this one is in terms of week. But then bila tiba-tiba your equation ask in terms of day, bila you nak masuk dalam equation, you kena tukarkan week dulu. Okay, so that is the difference lah. Bila kita gunakan week, make sure from the first place data tu pun juga menggunakan week. So bila you dah calculate, you akan dapat nilai 19.4631. So at the end of this, you can also comment on that one. So that means you akan cakap when the number of week employed is 8 weeks. So the point estimate of cars inspected is 19.4631. Okay, so in terms of this explanation, as you can see, when the number of week employed is 8 weeks, so kita dah tahu dia the point estimate. So sebab apa saya cakap pasal point estimate? Sebab kita punya formula ada y hat kat sini. So dia adalah approximately. Approximately itu maksudnya menghampiri 19.4631. So you buat je dalam bentuk perpuluhan. Okay, sebabnya in terms of data ni, in terms of estimation, sebab kita dah mention point estimate, so doesn't matter lah bila you buat 19, mana ada cars 19.4631 kan. But then you boleh buat bila you place actually point estimate. Okay, so you boleh cakap dia adalah approximately 19.4631. Okay, so this one adalah in terms of the punya explanation for kita punya jawapan dalam D. Okay, kita move forward kepada kita punya next example, which is example 2. Okay. So for example 2, which so for example 2, it is about example 5 based on example 2, right? So example 5 based on example 2. So kita pergi kepada the next one, which is okay, whatever it is. Salah kat nama ada pun blank page dia masuk tadi. Okay. So okay. From the example 2, previously, now it is example 5, right? So kita sebenarnya menggunakan data daripada example yang kedua. So based on this example, as you can see, our equation is still the same. The first one adalah obtain linear regression line, and then the second one explain the meaning of the constant A and B, which is beta naught and beta 1. Calculate the coefficient of determination, which is R square, and then predict the amount of safe if the mother is 40 years old. So 40 years old means X equals to 40. So you to predict the outcome. Okay, so kita akan proceed with our calculation. So for example, this example, we have example 2. As usual, I akan keluarkan dulu dia punya nilai. So the value for summation of x is equal to 217, summation of y which is 21, summation of x square which is 6187, summation of y square which is 69, summation of xy which is we have 626, and then we have n equals to 8. This one is based on our previous tutorial for not tutorial, video number 5, right? So based on that example, you boleh keluarkan this particular value. So the next one adalah kita dapat dah nilai. Kalau previously tak dapat nilai lagi kan, so this one kita dah dapat dah nilai. So based on this, kita ada nilai SXY, which is 56.375, and then XXX we have 300.875, and then SYY is 13.875, and then we have your R, which is equal to 0.8725. Okay, so this one adalah your value from the previous calculation. So first kita akan cari dulu nilai yang kita nak cari, which is kita punya regression line. So y hat equals to beta 0 hat plus beta 1 hat x. Okay, so beta 1 dulu kita akan start dengan beta 1, which is xxy divided with xxx. So xxy adalah 56, okay, 56.375 divided with our xxx, which is 300.875. So for beta 1, you will get the value, which is 0.1874. Okay, so this one adalah for beta 1, and then move forward to beta 0. So for beta 0, which is equal to y hat y bar, y bar, not y hat. So y bar minus beta 1 hat, and then we have x bar. So this formula come out with the value of y, which is 21 divided by 8 minus 0.1874, our beta 1 hat, and then times with x bar. So our x bar, which is 217 over 8. So you will get this value, which is equal to negative 2.4582. So the result would be y hat equals to beta 0, so negative 2.4582 plus 0.1874 x. Okay, so you will check that. Hence the regression line is this one. Okay, so we move to the next one. For the next one is explanation, in terms of explanation. Okay, so move forward to beta 0 first. So beta 0 is equals to negative 2.4582. I'm going to use black text. So negative 2, okay, means that when mother's age, which is x, is 0, the amount of money should be saved, which is our y, will decrease by 2.4586. Okay, so when you get this value negative, so instead of writing this negative, you buat this sebagai will decrease ataupun will be negative 2.4583, ataupun kat sini you boleh buat sebab dia punya harga tu in terms of ribu, right? So RM berapa? 2, 4, 1, 2, 3, right? So 1, 2, 3, 2, 4, 5, 8.20. Okay, so in terms of dia punya value ni, bila x equal to 0, means bila tak ada kat sini x equal to 0, kita punya y ataupun kita punya nilai untuk duit tu money saved by the mother when x equal to 0, bila mother's age tu tak ada, so adalah negative 2,458 ringgit 30 sen. Okay, so in terms of this one, bila you tak nak buat dalam bentuk RM ni, let's say like you forgot kan, but then in terms of dia punya unit, you kena buat macam ni lah. Okay, so mesti state dia punya ni in terms of ribu, ataupun you boleh buat macam ni in terms of dia punya decreases ni pula, daripada you buat decrease by berapa, you boleh juga buat will be, negatif ni jangan lupa. Okay, so yang penting you faham macam mana cara nak explain. So means that when x equal to 0, y kita will be berapa, okay, in terms of data note lah. So for data 1 equal to 0.8 0.1874, so you boleh put as 2, means that every increase in 1 year of mother's age, ataupun every increase in mother's age by 1 year, you will cakap juga, is explained by the amount of money, the amount of money will be saved is ataupun will be, tak kisahlah, so RM berapa, 1874. Okay, so from this one 1, 2, 3. Okay, so you will get 187 ringgit 40 sen. Is it 1, 2, 3, right? So 1, 2, 3, 1717. Okay, every increase in 1 year of mother's age, the amount of money will be saved is 187 ringgit 40 sen. Okay, so that one adalah in terms of explanation for B. Okay, let me see. Okay, so let's continue with our question C, which is to find the coefficient of determination. So in order to find the coefficient of determination, previously our R is 0.8725. Okay, so 0.8725, if you want to find the coefficient of determination, you need to find R square, which means you square this value of coefficient of correlation. So 8725 square, so you will get 0.7613. Okay, so since R square is equal to 0.7613, so you means that you can write it like this: 76.13%. As usual, the total variation in Y, which is our amount of money saved, which is Y, is explained by mother's age, which is X, while the mother 23.87% of the total variation is explained by other factors. Okay, so that one adalah in terms of explanation for this value. So total variation in amount of money saved is our Y, is explained by mother's age, which is X. For another 23.87, so this one kita cakap lah before this in example 5. So we have apa 1, you have to minus 1 minus 0.7613, 0.7613, then you will get 0.2387. Okay, this one in terms of percentage adalah you just darabkan dengan 100%. So bila you times with 100%, you akan dapat 23.87%. Okay, that one adalah untuk R. Okay, so the next one is what you need to observe is our D. Okay, so for our question D, which is kita punya expected based on this question. So based on the question, they said when the age of the mother is 40 years old, how much money did the mother can save. So the estimation for the money should be, okay, so this one is predict the amount saved if a mother is 40 years old. Okay, so based on this, you type to our model, which is our regression equation. So y equals to negative 2.4582 plus 0.1874, and then you just masukkan sahaja this one because kita punya from the first place kita punya data is in terms of years, right? So it is still the same without changing anything. So our y should be 5.0378. Okay, so at the conclusion, you can see when the mother's age is 40 years old, the point estimate of the money saved is RM. This one in terms of ribu, right? So in terms of ribu, let's see. Okay, to save money in terms of ribu, right? Like this one RM 0000. So that means you can just times with 1, 2, 3. So amount of money that needs to be saved is 5037 ringgit and 18 cents. Okay, so this one adalah dia punya explanation. So in terms of explanation, you need to really careful about the unit. Like this, we are using years, 40 years old. So the point estimate at the end of the analysis, if you are using RM, you can just write the final answer by 5,087 ringgit and 80 cents. Okay, so you need to change the unit first because in terms of answer, we need to make a clear conclusion, right? So that's it. So that one adalah untuk our ni. Okay, so the next one adalah based on our question. The next question, which is example 6. So you go to example 3. So this one basically is similar data from example 3, and then the equation is still the same. Obtain the linear regression line, and then explain the meaning, and then calculate the coefficient of determination and explain the value, and then predict the extraction efficiency when the extraction time is 5 minutes. Okay, so for the third example, for the third example, let's add another blank page. Might be 2 blank page. Right. So as usual, blank page. So proceed with our third example. Okay. So for the third example, I need you to come up with the value. So the value for example 3 based on our previous data, which is we need to come up with the ni lah. So we have example 3. Okay. So for example 3, summation of x is equal to 3 to 0, summation of y which is equal to 6, 3, 5, summation of x squared which is 1490, summation of y squared which is 41395, summation of xy which is 21275, and then we have our n which is 10, and then xy. Oh, sorry, the bird sounds louder than me. X, we have 1250, and then we have xyy which is 1072.5, and our r is 0.8248. Okay, so based on this information, what you need to observe, what you need to calculate is the first one lah. Kita to find the regression line. Y equals to beta naught hat plus beta 1 hat x. So beta 1 hat, beta 1 hat which is equal to sxy divided with sxx. So you have sxy 955 over, we have sxx 1250. At the end of this calculation, you will get 0.1874. Okay? Okay. So the next one is our beta naught. So for beta naught, which is y bar minus beta 1 hat x bar. So based on this one, I'm sorry, the bird sounds louder than me. 635 over our n which is 10 minus beta 1 hat 01874, and then you times with our x bar. So our x bar should be 320 over 10. Okay, so at the end of this calculation, we will get the value of beta naught hat which is 59.052. Okay, so for the final answer, you will say that as usual, the regression line is, so we have y hat equals to beta naught which is 39.052 plus with 0.1874x. Okay, so this one adalah kita punya regression line. Okay, I'm sorry, I think it is wrong at this part. Saya ambil daripada previous pula. Wait. So this one adalah wrong, which is supposed to be, the value should be 0.764. Okay, so this one adalah 955 divided with 1250, we will get 0.764. So this part is it is 0.764 lah. Okay, this one. Okay. So, okay, let us continue with our second part, which is B, in terms of explanation as usual. So, okay, so the way you explain this, beta naught first. Okay. So, beta naught is equal to 39.052. So you can say that means that, so this time our x and y is lain lah. So means that when the extraction time is 0 minutes, okay, sebab dia dengan minit kan, so bila kita bercakap yang ni adalah when x equal to 0 lah. So when the extraction time is 0 minutes, the extraction efficiency will be 39.052%. Okay, sebab yang ni sebab dia adalah dalam bentuk percentage. So macam saya cakap lah, bila you ada unit, you can try to use that unit. Okay, so you have 39.052, and then the next one adalah for delta 1, which is 0.764. So means that every increase in the extraction, I'm sorry, yeah, that is 10 extraction time, every increase in the extraction time by 1 minute. So we can say that by 1 minute, the extraction efficiency will be 76.4. 76.4. Okay, so maybe 76.4%. Okay, we can do this in terms of percentage, since kita ada we are using percentage in terms of extraction efficiency, and then this one extraction time in terms of minute. So you need to reconsider ataupun consider dia punya unit when you want to explain the data. So for this one, data not had is equal to 59.052, means that when the extraction time is 0 minutes, the extraction efficiency will be 59.052%. So for the next one, adalah data 1, means that every increase in the extraction time by 1 minute, so every increase in 1 unit, the extraction time will be 76.4%. So that one adalah key. So for the next one is question C, in terms of kita punya soalan dalam example 3. Saya ulang balik. So example 3 ataupun example 6 kan, example 6 based on our ni lah topic this one, example 6 before to example 3. So either one lah. So kita akan continue dengan kita punya soalan, which is C. So untuk C adalah previously kita ada nilai R kita, which is 0.8248. So as usual, apa yang you akan cari adalah dia punya nilai R square. So untuk R square, you just square saja R ni, which is you akan dapat 0.82 for 0.8248 consider, kita akan dapat 0.6803. Okay, try to calculate this one. So in terms of explanation, dia akan seperti kita explain lah macam biasa. So 0.6803, so you will see that means that 68.03% of the total variation in Y. Our Y is the pen is missing. So in Y, which is the efficiency of the extraction. Manilah extraction efficiency, kita kisahlah extraction. The efficiency of the extraction is explained by our X, which is extraction time. By the extraction time. Okay, so ini adalah kita punya Y, yang ni adalah explained by X, and then the balance is while another 31.97% of the total variation is explained by other factors. Okay, so this one sangat penting lah. The other 31.97% as usual. Dari sini you all boleh buat 1 minus 0.6803 and then ataupun you ambil 100% minus dia dengan 68.03%. So you akan dapat this one lah, dia punya balance. Okay, so that one adalah untuk C and then proceed kepada kita punya D, which is berapa banyak yang perlu kita masukkan bila extraction time adalah 35 minit. Okay, predict the extraction efficiency. One can expect when the extraction time is 35 minutes. So based on that question, you kena masukkan balik dalam your Y, which is Y equals to, ada Y equals to 39 previously dalam calculate beta naught plus beta 1 0.764 and then you masukkan nilai 55. Okay, so sebab dalam question ni memang asal-asalnya memang dalam bentuk minit, so tak ada masalah lah. Let's say dia beritahu kat sini dalam bentuk saat, so you boleh jadikan dia minit. Okay, so your head akan dapat Y head which is equal to 65.792. Okay, so in term of explanation you boleh cakap when the extraction time is 35 minutes, the extraction efficiency will be ataupun the point estimate or saya tinggal the point estimate of the extraction efficiency, the point estimate of the extraction efficiency will be 65.792. Okay, so this one adalah dalam bentuk percentage dah lah, sebab yang ni dia beritahu dah dia memang dah dalam bentuk percentage. So that one adalah in term of degree percentage, so 65.792%. Okay, so this one adalah dia punya last sekali lah in term of explanation. So I hope you all can understand what I am trying to explain based on our example. So kita ada example 4, 5 and 6. So 4, 5 and 6 ni regarding our linear regression line and then explain the meaning of A and B. So for A and B tu adalah beta 0 and beta 1. Okay, so and then the equation, the calculation, calculate the coefficient of determination, so which is R, you square kan here, and then explain the value obtained. That is why saya suruh explain. Dia nak explain the R square ni, make sure you buat dalam bentuk percentage, okay, in terms of explanation. And then the next one is predict the extraction. So ini in terms of prediction. That's why one of the use ataupun benefit bila kita gunakan linear regression adalah untuk predict the future ataupun the future outcome. Okay, I think that is all for the explanation regarding our second part in topic 3, which is correlation and regression. So I hope you all can understand what I'm going to explain right here. So this time adalah more kepada dia punya explanation lah. Okay, explanation dalam regression punya line. Okay, regression line. So you obtain the regression line and you explain the value, and then you need to explain also the R square, coefficient of determination, and explain in terms of the result, the expected future outcome lah. Okay, that's all for that. Thank you.
Okay, this is the general interpretation of A, which represent our beta naught, and B represent our beta 1, and R squared, which represent the coefficient of determination. Okay, thank you.